For decades, tanks represented one of the most intimidating sights an infantry soldier could face. Dozens of tons of armor, heavy firepower, and enough mobility to break through defensive lines. Then came a weapon that allowed two soldiers hiding behind a wall, inside a building, or along a tree line to threaten even a modern main battle tank. The FGM-148 Javelin. Compact, portable, fire and forget, and capable of attacking a tank where its armor is usually weakest, from above, the Javelin has become one of the most recognizable anti-tank weapons in modern warfare. But more than 30 years after entering production, the Javelin is now undergoing another major transformation, and the reason is simple. The United States wants this tank killer to remain operational until at least 2050. So how exactly does the Javelin work? What makes it so dangerous? And after the explosion of cheap FPV drones on the battlefield, does a missile costing around $200,000 still make sense? Let's take a closer look. The Javelin began full-rate production in 1994 and entered U.S. Army service in 1996, replacing the older wire-guided M47 Dragon. Its biggest revolution was not simply its warhead. It was what happened after the trigger was pulled. Older anti-tank missiles, such as the Dragon or TU, generally require the operator to continue guiding the weapon toward the target during flight. That means remaining exposed while the missile travels downrange. Javelin works differently. The gunner first searches for the target using the Command Launch Unit, or CLU. Once the vehicle is identified, the operator places the aiming cursor over it and establishes a lock. That targeting information is then transferred to the missile's imaging infrared seeker. And after launch, the missile guides itself. The operator can immediately take cover, move to another firing position, or begin preparing another missile. That is the essence of Javelin's famous fire and forget capability. The complete legacy weapon system weighs roughly 49 pounds, or about 22 kilograms. The original Command Launch Unit accounts for approximately 14 pounds, while the missile round itself weighs around 35 pounds. That makes Javelin light enough to be carried and operated by a small infantry team without requiring a vehicle-mounted launcher. When fired, the missile does not immediately ignite its main rocket motor. Instead, it is first pushed out of the launch tube using a soft launch system. Only after clearing the operator does the main motor ignite. This dramatically reduces the danger of backblast and makes Javelin suitable for firing from confined positions such as buildings, bunkers, and urban fighting positions, locations where conventional rocket launchers can be much more difficult to use safely. But the defining feature of Javelin is what happens during the attack. The missile offers two principal engagement modes. The first is direct attack, useful against targets such as bunkers, fortifications, vehicles, or helicopters. The second, and much more famous, is top attack. In this mode, the missile climbs after launch, follows an arched flight path, and dives onto the upper surface of the target. That matters because a tank's frontal armor can be exceptionally thick. Its roof armor is usually much thinner. Javelin therefore avoids trying to overpower a tank at its strongest point and instead attacks one of its most vulnerable areas. When it reaches the target, the missile uses a tandem heat warhead. The first smaller precursor charge is designed to trigger or disrupt explosive reactive armor. Milliseconds later, the main-shaped charge strikes the armor underneath. Reported penetration figures cited for the system range from roughly 597 to 800 millimeters of steel armor, although real-world effectiveness depends heavily on armor design, impact angle, reactive protection, and where the missile actually hits. Modern Javelin variants have an engagement envelope of approximately 4 to 4.75 kilometers, and the missile's infrared seeker is central to virtually everything the weapon does. Once the missile leaves the tube, there is no guidance wire connecting it to the operator and no radio control link that needs to remain active. The seeker must recognize the selected target and continuously track it until impact. That autonomy is particularly important on battlefields saturated with electronic warfare. A radio-controlled drone can potentially be jammed. A Javelin that is already locked onto its target does not need a pilot transmitting commands throughout the attack. And that brings us to one of the most important Javelin developments of 2026. On August 6, 2026, the U.S. Army awarded Kratos Defense a contract to develop and manufacture a next-generation infrared seeker for the missile. The objective is not simply to give Javelin dramatically more range. The bigger problem is technological obsolescence. Some of the detector hardware, processors, microelectronics, and manufacturing technologies inside the existing seeker architecture were designed decades ago. Keeping a missile in production for more than half a century means suppliers disappear, semiconductor families become obsolete, and manufacturing processes eventually have to be replaced. Kratos will therefore develop a new production-ready seeker while the Lockheed Martin and RTX Javelin joint venture continues managing the wider weapon program. Modernization is also happening at the launcher. In May 2026, the U.S. Army received its first lightweight command launch units, known as LWCLU. The new launcher is approximately 25% lighter and 30% smaller than the Block 1 CLU, while roughly doubling target detection and recognition range day or night. Based on the legacy launcher weight, that brings the new unit to roughly 10.5 pounds. Importantly, the CLU is more than just a missile launcher. It can also function as a highly capable thermal observation system, allowing troops to detect, identify, and monitor targets without actually firing a missile. But no discussion of Javelin is complete without Ukraine. At the start of Russia's full-scale invasion in 2022, portable anti-tank weapons became critical as Russian armored columns moved through roads, settlements, forests, bridges, and other restrictive terrain. Javelin became one of the symbols of Ukraine's early defense. Some early estimates associated approximately 300 Javelin launches with 280 Russian armored vehicles neutralized. But that figure needs caution. Those vehicles were not necessarily all tanks. Multiple missiles may have been fired at individual targets, and taken out can mean destroyed, disabled, immobilized, or abandoned. What the fighting did demonstrate was something strategically important. Even a highly effective missile can disappear from stockpiles extremely quickly during a major war. By January 2025, the United States had committed more than 10,000 Javelins to Ukraine. That creates a major industrial challenge. Javelin production had been running at roughly 2,100 missiles per year. Lockheed Martin's planned capacity expansion targets approximately 3,960 missiles annually, about 330 per month. Even at that increased rate, manufacturing 10,000 missiles would theoretically require around 2.5 years if every missile produced went toward replacing those stocks. And then there is the question of cost. One cited Javelin missile price is around $200,348. Compare that with FPV drones costing hundreds or several $1,000s, some of which can fly well beyond Javelin's range. On paper, the economics look brutal, but the comparison is misleading if taken too far. FPV drones depend on operators and radio links. They can be disrupted by electronic warfare, bad weather, terrain, or signal interference. They usually carry smaller warheads and may require repeated strikes against heavily protected armor. Javelin offers something different. A soldier identifies the target, locks the seeker, fires, and the missile autonomously delivers a purpose-built tandem anti-tank warhead within seconds. So the future battlefield may not be about choosing between javelins and drones. It will be about using each weapon against the targets where it makes the most sense. Cheap drones for reconnaissance and mass attacks, and expensive autonomous missiles for heavily armored, urgent, high-value, or electronically contested targets. More than 30 years after entering service, the Javelin is therefore not disappearing. It is adapting. With a lighter launcher, a new generation infrared seeker, expanded production, and a service life potentially stretching to 2050, the FGM-148 could remain in frontline arsenals for more than half a century. The battlefield around it may change completely. Tanks will gain new armor, drones will become cheaper, electronic warfare will become more powerful, but as long as infantry soldiers need a weapon that can be carried on foot, fired within seconds, attack a tank from above, and guide itself all the way to the target, the Javelin will remain one of the most dangerous tank killers on the battlefield.